Lab 4, chip clip. Hi, Joe Cerrone. Today we're going to model this closing clip for a bag of crisps. And we're going to download and take a look at the file. The file is located right here with this image. And we can see that it's a metric drawing. It's 79 millimeters by 20 millimeters. I'm going to come back here to the AutoCAD. And I'm going to download this file, chip clip title block. I'm also going to download this image. And then I'm going to open the title block. And if you've downloaded the image and the title block, it should open with a copy of the image on it. And so what I've done is I've kind of set up the title block for you so that we can go ahead and draw this. And I've been thinking about the best way to model this as a new course trying to work with AutoCAD. And so we're going to try that today by switching over to model space. And you can see there's this is actually an image. If I click on it, and I right click and I say quick properties, it'll tell me it's a raster image. And what a raster image is it's a picture essentially. Alright, so let's try looking at this. We have a 79 millimeter by 20 millimeter area here, and this is like what the top view of it would look like. And then it's 16 millimeters tall by 79 millimeters. They don't really have a lot of dimensions here. And as we look at it, it looks to me like it's 3 millimeters thick all the way around. So what we're going to do is we're going to draw an arc. We'll go with a 3-point arc, and we'll go from here to here to here. And I'm going to update my color here. I'm going to change this to by layer. I'm going to do that. And you don't have to do this, because it's a little easier for me to see. And then I'm going to draw another line. Now, as we draw these lines, all the endpoints need to be connected since we're making a model out of it. And so I'm going to draw a line, and then when I hover over this, I'm going to use the O-snap endpoint. If your O-snaps are not on, you can click this square right here, and you can turn it on. It'll turn blue. And make sure that endpoint center should be highlighted as well. I usually run with these three here: endpoint, midpoint, center point, quadrant, intersection, extension. These are also good to have on. Alright, so once you've enabled the O-snaps, then what you want to do is you want to get the endpoint right there and then just bring it over like this. Hit escape. Get another arc. Again, as long as the boundary shapes, and the way the arc works is first point, second point, third point. Sometimes it'll flip on you and go backwards. It's just sort of how this CAD program sort of works. Hit escape. Arc. And so this is not a bad way to go through and to work with this. Now, even though this one arc didn't work exactly like I wanted it to, if I click on it, I can kind of massage it into shape with the grips. And again, it doesn't need to be perfect. And remember, this chip clip is going to open and close. We don't want these parts touching because they'll fuse together, and then when we 3D print it, and we'll have to break it or find a way to keep them from being attached to each other. So again, I'll just continue this to this point right here. I'll hit escape. 3-point arcs seem to be working pretty well for us this morning. I'm snapping on the grid a little bit, so I may turn that off. And so what I'm going to do is I'm going to type in snap, and I'm going to turn the down arrow, and I'm going to say off. Now my image sometimes goes behind the other one, so oftentimes you just have to redraw or refresh the screen if it does go back there. The other thing that you can do is you can click on it, and then you can go, as long as your menu bar is on, you can go and move it to the back. So to move that to the back, we'll go to Tools, Draw Order, and Send to Back. Notice that I have it gripped, so it's highlighted. And so that way that's sent to the back, and then our line should be on top. 3-point arc, endpoint, line, arc, line. And what I'm doing is I'm hitting escape when I'm done with the line command. You can hit escape or you can right click, select enter. Now this is just a prototype, so it's not perfect from a standpoint of circular geometry and tangency points. I tried to do it that way and it was just so complicated. I thought, well, it's just a chip clip, and it's actually kind of nice to have it for everybody to have sort of their own design. So just by tracing over this existing bitmap, I think we'll be just fine. Because really the end goal here is to be able to come up with a working prototype that we 3D print. Just make sure that the geometry is all endpoint to endpoint as you create it. And if it's not, you can click on it with a grip and then you can kind of fuse them, and I'll show you what I mean by that. So for example, if these two lines weren't endpoint to endpoint, I could click on one of them and then I could move it. I could move it back. If I click on this one with the grip, make the one grip hot, bring it over to the other, click, and now they're endpoint to endpoint. So that's the basic shape of the part. What I'm going to do is I'm going to copy it over to the side. And then I'm going to make it into a region. And you can either make it into a closed boundary shape by a number of different ways. Region seems to be the most popular, and so all the new books are using region. I used to use p-edit and join, which accomplish the same task. So again, go under the draw menu, select region, or just type in region. And what is a region? Region is basically a closed boundary shape. It basically changes to a filled color like that because it's a closed item. In other words, there's no gaps. Change to an isometric view, and then extrude the part, and the part is 16 millimeters high. I guess it's 16 high. The thickness of it, I guess we'll go with 20. So we'll say extrude. Select the item, hit enter, and then go up or down. We'll say 20. And then we can save it. Save it with your initials. And so this will be JC-Lab 4. We'll go ahead and update these relative paths. This was with the image that we inserted. Alrighty, we can export it. Other formats, lithography file, save, click on the part, hit enter. The other thing we can do if we wanted to would be to add some kind of an initial on it or something like that. At this point, I'm not going to worry about that because this was a little bit difficult to model. And so we can then take this into our DigiSlicer. And so if I go down to Dremel and I run the Dremel DigiSlicer, and we can open that STL file. Now sometimes we have to do a conversion on the file because it takes metric millimeter units. This one came out perfect, so my title block is set right. Terrific. So the next thing to do is just to look at how you'd want that printed, and this is really a great orientation because we don't need any support material. And what I'm doing is I'm right mouse clicking and moving the mouse. Navigating the Dremel slicing software is a little bit different. It takes a little while, but if you turn the wheel on the mouse, it'll zoom in and zoom out. If you right mouse click, you can kind of navigate, zoom, and then if you push the wheel on the mouse, you can kind of get a bit of a panning sort of a approach to it. We're going to make this with PLA. Let's see if I can find my computer on the network. These Dremels, they have some really cool features, but they're a little hard to get networked. Connect via network. No, it's not finding it now. And I'll work on that. Seems like the networking has always been an issue on this, but that doesn't matter because we can print it to a USB and work it that way. So material, we'll run this with PLA, polylactic acid. Quality level, I usually start off with low quality and then I'll bring it up from there because it prints faster. As far as these other settings, we're going to leave them alone. The layer height is 0.3 millimeters. As we start to go through and work more with our slicing software, we'll start to look more into it. I'm going to say prepare. And then if I want to look at this, I can go to the layers and I can then go through each of the different layers and see how that's built. Looks just fine. So I'll put in USB and I'll save it to the removable drive. The time required to print this is 32 minutes and the file name is going to be D3 JC-Lab4 and that will be a G-code file that will drive the 3D printer. Alright, that completes this video for the chip clip.